Alright guys, so we have 3 things to add to our notebook today. This one here, which is page 3 of that first document, and then I actually printed page 3 and 4 on the same page so that it would be smaller like this, but if you just, don't, that's fine. And then I have this little book here, and then on the next page I have a book that looks very similar to it, but they are different. So these are on pages 116, 117, 118, and 119. I actually didn't put anything on 118 yet. Okay, so when it comes to area, we talked about a lot of area formulas, but they were all for quadrilaterals. So those are pretty small shapes, and now we need to ramp it up a bit. And so for larger shapes, polygons, like a pentagon, hexagon, heptagon, octagon, all those things that we talked about with the polygon sum theorem, we want to be able to find the areas of those things as well. And so as long as they are regular, so the area formula for regular, and I think I talked about what regular means there also, but regular means that all the sides are the same and all of the angles are the same measure. So an area formula for a regular polygon is half AP, where P stands for perimeter, so that's super easy, and A is this new thing that we're going to take a look at right here called an apothem. And so an apothem is super fun to say because it sounds like a possum, but a lisp. And I kind of have a lisp, so it's okay for me to say that. So an apothem. Now what an apothem is really a height, but it's not like the full height of a shape. It's the height from the center to a side. So center to side. So for instance, if we look at these 3 regular shapes right here, the apothem in all of them is represented with this dashed line. So because that's going from the center of the shape down to a side. And it's a height because it's perpendicular. So this is your apothem in all of these shapes. And hopefully they tell me what my apothem is, and they tell me the length of my side, because then finding the perimeter is easy. Okay, but we're not always that lucky, and so sometimes we have to use other things to figure that out. So this here is called the center. Now usually what we use the center for is not the point itself, but usually we want this angle right here, so we kind of want our central angle, which we have a little formula for that, which we'll get to. This right here, on all these shapes, oh, here we got a central angle, so center and center. So then kind of the next thing that we're pointing to is this length that's coming from the center to an angle, which that's different than an apothem because an apothem goes to a side. So center to angle is actually called a radius, which maybe feels a little strange to say because in circles a radius doesn't go to an angle, but circles don't really have angles or sides, so I don't know, kind of doesn't make sense. So radius. And then the last big thing that you need to know, or you're hoping that you know, is the side length. So this is the side, and that's important because in a regular hexagon, I can find the perimeter by doing side times 6, because a hexagon has 6 sides and they're all the same. Now in a regular quadrilateral, aka a square, your side, fine, I can find the perimeter by doing side times 4. And so in general, we can always find the perimeter by doing side times however many sides you have. And my little curly Q didn't show up here, but that boy there is your side, and that's helpful because if I want to find perimeter, we're going to do side times 3 for a regular triangle. Now for a triangle, I have other formulas I could use, like half base times height, but I might use half apothem times perimeter if it's an equilateral triangle and I know the apothem or I know the radius. Same thing with a quadrilateral, like I know how to find the area of the square, but I could use half apothem times perimeter if I know the apothem or if I know a radius. So that might be a reason that you want to do it. Okay, so we're going to try some now. Sure, we'll start with the hexagon. So let's say, for instance, we know the apothem is, do I want to start with that? Yeah, let's start with that, 6 root 3. Okay, so if I want to find the area of a hexagon, the only way I can do it is half apothem times perimeter. Now the thing is, right now I know the apothem, it's 6 root 3, and I need to find the perimeter by doing side times 6, right? Because I have 6 sides and I need to know how long they are, and I don't know how long they are right now. So that's why, if you notice in that other picture, I always had the apothem and the radius drawn. So I can also draw the radius here. And what happens then is I get a right triangle, which is super nice because in this little right triangle here, I can maybe use some things about a right triangle to find this length, which should help me find the side length of the hexagon. So I talked earlier about that central angle. If you think about it, if I go all the way around the center of a shape, I've traveled 360 degrees. This is how we find our central angle. However, when I draw in all the radii that I can draw here, it ends up splitting your hexagon into 1, 2, 3, 4, 5, 6 of those. So we always divide by however many sides we have. So in this case 6, so we're at 60 divided by 6, we're at 60 degrees. But then whatever number I get there, I also need to then split in half, because I then drop in that apothem and it cuts this central angle right in half. So I split this in half now, and lo and behold, that top angle is a 30-degree angle, which is super duper good, because I was feeling a little worried we only had one piece of information on that triangle, but now that I know it's a 30, 60, 90 triangle, I can figure out the rest of the sides. So on my 30, 60, 90 triangle, I know the longer leg, which is where the root 3 is supposed to be. So to get that shorter leg, we just take the root 3 off, and so this length right here is 6, making your radius 12. Not that I really need it, but because this is actually an equilateral triangle, because 30 and 30, and then you have 60 right there, that makes this 6 right here as well. And so you're always just going to double your side, so your side length is 12. So yeah, half times 6 root 3 times 12 times 6. Now, just like we talked about with finding the area of a triangle, you only are allowed to take half once. So you can pick and choose what you want to take half of, but once you've done it, you're done. So I'm going to take half of the 12 just because it's a lot largest number. So then I have 6 times 6 times 6. Ooh. So 216 root 3 units squared is my area. Da, da, da. So that's kind of a harder example. Hopefully they just tell you apothem and side length and you can do it, but I'm going to do harder examples with you. So let's try another. So let's say we had the apothem there. Let's say, for instance, on this triangle, they told me that the radius is 18 inches. Sure. So because they gave me the radius here, I don't want to do half base times height. I definitely want to do half apothem times perimeter. And so I don't know my apothem. Oh, this is going to blow. And I also don't know my side length, because really, maybe I'm going to replace perimeter right now with like, I'm going to do side times 3, because that will give me my perimeter. And I don't know the side length either, so that's really a bummer. So if we draw in that apothem, because I definitely need it, this will be my apothem. This is going to be half my side. Finding that central angle is key, because then that will give me more information about this right triangle down here now. Okay, so if we do that 360 divided by 3, because I have 3 sides, I'm at 120, and then we split it in half again, so I'm at 60. So that top central angle there near the center is 60 degrees, which again is super nice, because that means I'm a 30, 60, 90 triangle. And on my 30, 60, 90 triangle, I know the hypotenuse. So since the hypotenuse is 18, your shorter side, which is across from the 30, is half that. So your apothem is 9. And then when I go from short to long, I put that root 3 on. And so this side length here is 9 root 3, but then the full side that I need is going to be 18 root 3. Okay? So I have half my apothem, which is 9, times the side length, which is double this, so that 18 root 3 times 3, because I have 3 sides for the perimeter. Okay, so again, I can take half wherever I want. I don't want to take half of 9 or 3, so I'm going to take half of the 18. And then 9 times 9, we're at 81 times 3, so 243 root 3 inches squared. Is my area. Okay, we'll try one more, which, so we had one where I had the apothem. We had one where we had a radius. So the only other thing that could happen is that they tell you your side length, which, like, probably shouldn't have saved it for the square, but I mean, whatever, it's fine. So let's say that your square side length was 20. Now if it's 20, like, I know then the area is just 400 because I can do 20 squared, but let's for funsies do our half apothem times perimeter. Okay, so I don't know my apothem, but I can find my perimeter by doing the side length times 4, because there are 4 sides, and I know the side length is 20. And this will be interesting too, because we know that it should be 400, so we'll see how this area formula works out, and it still gives me 400 for the area. Okay, so I gotta find that apothem. So we always draw in that right triangle that includes your apothem and your radius. And when I do that, like, it takes your 20 and actually splits it in half, so like this side of this little right triangle is 10. And then we want to find that central angle, so we did the 360 divided by 4, because I have 4 sides, which is 90, and then I split it in half again, and so that top central angle is 45 degrees, which again is so nice, because I have a 45, 45, 90 triangle, and on a 45, 45, 90 triangle, if one leg is 10, the other leg is 10. And then your radius would be 10 root 2, not that I really need it, I just needed the apothem, so now I have it, it's 10. Oh my gosh, the really interesting thing about a diagonal, no, come on, don't forget Missouri. So now I'm going to take half of whatever I want to take, I'm going to take half of the largest number, so 20, and then 10 times 10 is 100 times 4 is 400 for that area of 400. Now, with the square, we said we could also find area by doing side length squared, so like 20 squared, 400. But you can also do that at half d1 times d2, and the interesting thing here is that this is part of your diagonal, and so like your full diagonal is 20 root 2, so if I do half 20 root 2, and in a square they're the same, so times another 20 root 2 for your other diagonal, half of 20 is 10, 10 times 20 is 200, root 2 times root 2 is root 4, which is 2, which is 400. Oh my god. Okay, sorry, freaked out. So on the inside here, you'll notice that you just have 3 more of the same shapes. So I'm just going to put them here because it's easier for me to write. I'm going to give you 3 to try like this. So we'll do on the hexagon, draw your little apothem radius triangle in there. We're going to say on the hexagon, you know that the side length here is 8 centimeters. And I'll have you guys try that one. On the triangle, I'll tell you that your apothem is 4 centimeters. And then on your square, we're going to say that that radius is 11√2 centimeters. And guys, for all of these, I think it's important that you try your half apothem times perimeter to do this. So try that formula. Okay, so this is going to be kind of a long video because we have to try the other one as well, but you're not going to have any homework on top of this. You're just going to try these 3 examples and then 3 more. So it's kind of a lot. I'm sorry, but it's kind of a review too, like the 30, 60, 90 stuff, 45, 45, 90 stuff. Okay, so now you can notice on this one we have slightly different polygons. Like here we have a pentagon, but I can still use half apothem times perimeter as long as it's regular, and we're going to assume that it is. And so let's say, for instance, on that pentagon, we know that the side length is 10. So I can do half apothem times perimeter. I don't know my apothem yet, but I can find the perimeter by doing 10 times 5, because the side length is 10 and there are 5 sides. But I got to draw in that apothem and then we got to figure it out. So just like with the other ones, I'm going to draw in that right triangle that we get right here, and I'm going to find that central angle. So 360 divided by 5, because I got 5 sides. Oh my word, calculator. 72. And then I split it in half again, which is 36 degrees. Alright, we did it. I'm going to need a calculator in a second though, so I might have to pull up Desmos here. So that is 36 degrees, which is not a 30, 60, 90. Or if I 45, 45, 90. Oh, and I should say too, when you drop that apothem in, that 10 side length, now on this little right triangle here, that boy's 5. And I need to know my apothem right here. I don't really care what my radius is. And so the trouble was, if you remember back to our right triangles, I could find a second side if I had 2, or I could find the third side if I had 2 sides, but I don't know the radius. And it's not a 30, 60, 90 or 45, 45, 90. And so if none of those things worked, I had to use trig. And so here I have to use sine, cosine, or tangent to figure out A. And so we always based it off our angle, and so since my angle is here, and the side that I know is opposite of that, and the side that I want to know is adjacent to that and not the hypotenuse, opposite and adjacent, that's tangent. So we want to do tangent of our angle equals the opposite side, which is 5, over the adjacent side, which is our apothem. And if you remember, when it came to solving trig functions, there was only one of 3 things that could happen, and if a was under, if my x was under, we just did a little swappy thing right here. And so a comes here, and we're going to do 5 divided by tangent of 36. So I'm silly and didn't bring my calculator, so I have to bring up Desmos. And I don't know if you guys are going to see this the way that I'm recording right now, but that's okay if you do, no biggie. So let's see. If I type in, we've got to do 5 divided by tangent of 36. Come on, Desmos, I know you can do tangent for me. Degrees. This is not doing this correctly. And I put a degrees button. Is that a thing?